Hey everybody, welcome back to Adventures in Machine Learning. I'm your host today, Ben Wilson. Michael is off this week. He'll be back next week. But today on the podcast, we've got a special guest, Michael Griffiths, and we're going to be talking about a whole range of topics. But this is going to be more production ML, specifically around rather advanced production use cases of machine learning and the intricacies and complexities that arouse around that paradigm. And so introduce yourself, Michael. Tell us who you are, and we can get started with talking about some fun stuff.
Yeah, thanks for having me on today. I've been doing ML type stuff for around a decade now. I'm director of data science at ASAPP, part of the research team. ASAPP itself is a research-based artificial intelligence software provider, and we're kind of committed in targeting the enterprise space and how their customers engage. So we advance the state-of-the-art in a variety of areas: automatic speech recognition, natural language processing, task-oriented dialogue. And we're really trying to think about how can we bring cutting-edge AI systems and software to large enterprise customers to help them solve their customers' problems better.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv. And I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
Yeah, one thing that we were talking about before we started recording was this, like a main use case that you have at your company is offering these solutions that help to augment, the human element of sort of customer service. And a lot of people in that are outside of our space tend to see AI and ML as like, oh, it's replacing our jobs and it's going to completely automate us. But it seems like what you emphasized in our lead up to starting recording was augmentation of human activity. Could you talk a little bit about that and like where that falls between those two polar opposites of fully human controlled versus fully automated?
Yeah, absolutely. And that's a great way of putting it. When we started in 2014, we started with really a chatbot type provider. And the goal was to take work away from people. And our thought process was, hey, the artificial intelligence can do some of that work. And we very quickly ran into the problem that machines are good at the head of the problem, like the first 20, 30, 40% of the problem. But there's a really long tail going on there. And you're restricting yourself to kind of only part of the problem space and maybe not as interesting part of the problem space as we might think. So if you have on the one end sort of this binary idea that you can use AI to completely eliminate humans, or on the other end, your alternative is, hey, you have to have humans do everything. We live a little bit in the middle, where how can we design AI systems to augment people doing the work? And there are a bunch of nice byproducts of that. For starters, you can make the work more interesting. You can try and sort of take away the pieces of the work that are routine or boring, and you can focus attention on the pieces of the work that are more interesting. So in customer service applications where we're trying to provide a way for agents to have a higher service level and a sort of more empathetic and human connection with the customers they're talking to, precisely because we can augment those individuals and take pieces of the work away that are frustrating or difficult or sort of mentally taxing, and lower the cognitive load of the work they're doing so they can focus on the important bits.
So if we're talking through a simulated environment here, I'm calling my cell phone provider company and saying, hey, I've got this really weird charge on my bill. With augmentation, you don't run that into that trap of, okay, I'm talking to a bot that does not understand the concept of, it picks out words of like, I have a question about my bill. And it's like, how would you like to pay your bill today? These
exactly.
Automated canned responses. But when we're if we're interfacing with a system where it's a human and a machine, or if it's just pure human, and we start talking about that bill, we now need to do account validation. They have to go into a window on a computer and log in as you to get your bill, and then they have to read through it and find that line that you're talking about. So with this augmentation, you're saying that the AI bot could be reading or listening into the conversation that's happening and asynchronously pulling up that information so that the customer support person doesn't have to go, put that customer on hold for 10 minutes while they get that data.
Yeah, and that's a good example. So take the communications example. If you're chatting into a customer service representative using your cell phone or you're on a browser, and then the agent on their end might be handling not just you, but one or two or three or four other customers at the same time, and trying to juggle a lot of mental overload. And they're interfacing with quite complicated internal tools that their companies have built for them. And that's great, but it's a lot of work. It's a lot of stress. It's a lot of attention. So we can do things like say, hey, we understand what the customer is going through. We understand what the agent is likely to say. We can automatically recommend talking points to the agent, either sort of full and complete sentences or just bullet points. We can identify where the information is inside their internal tooling systems by tracking the way the agents are working on their tools themselves and identifying where sort of successfully resolved conversations, where did they get that information? We can recommend that to the agent. We can automatically pull that back. We can incorporate that into the responses themselves. We can try and automatically pull up, say, hey, you may not know how to solve this problem, Miss Agent, but here's the knowledge base article that your internal company has. Here's when you should look at it. Here's where you should look at it. Here's what you need out of it. And we can try and sort of find that and pull all of that together for the agent themselves. And that relies on quite a lot of machine learning to do all that.
A staggering amount. I was just itemizing and enumerating all of the different models that you would have to build there, but that's fascinating. And I think I've seen this sort of behavior as a consumer myself. I've seen the dumb bots that are full automation. You just get super frustrated. Like, what is this? I'm talking to not just an AI bot, but a dumb AI bot that's been trained poorly. And then some companies I've interacted with on their online chat, I'm like, I can't actually tell if this is a human or not. And then I usually do a small test. I'll try to say, tell a joke or say something super sarcastic. And that's the real telltale. I'll be like, okay, it's a robot. A really, really good AI has been set up. And it's probably been talking to your company software, which is pretty cool. So one thing that I am curious about is if you're deploying these at a company that might not have the best reputation with its customers and the internet is full of trolls, people are going to interact with these text processing bots. How do you limit the reinforcement learning phase with these to say, okay, I need to identify malicious behavior and make sure that the bot doesn't learn how to do that or learn how to interact with that incorrectly?
Yeah, that's a great question. Where our position is we put the agent at the heart of the experience. We're trying to learn from how humans actually behave. And so we focus on, well, what would an agent do in this situation? Can we learn from previous agent experiences? Can we customize our recommendations to that individual agent themselves? And can we really, really put them at the center of it? Because ultimately, as we do more and more augmentation and more automation, the human touch is going to be where more and more of the value resides.
Fascinating. Is there ever a state in which you need to identify a rogue actor at the actual company? Like, hey, we can't use this person's training data to retrain this bot because they did everything wrong.
Absolutely. And there's a nice little anecdote about this is one of our customers had a situation where one agent was really, really good at upselling a particular support plan. They're amazing at it. They had an attach rate like 10x the next agent. And so you kind of look at that and say, hey, well, why is this agent so good? What are they doing? And can we get other people to replicate that behavior as well? Well, it turns out that there was a sort of a free support tier. And this agent was telling customers that to get any help whatsoever, they had to pay for the premium support tier.
Nice.
Yeah. So you need to be a little careful about blindly learning from behavior, because you also need to balance, hey, what is in compliance? What is in scope? What is the quality of this? there's a lot of very important work that agents do that is not designed only to sort of help the customer as quickly as possible or to get them off the phone or to make them really happy, but is also designed to sort of help the company be sustainable over time. And that can be the most obvious example is reading legal disclosures to limit the liability of the organization. But there's other work as well around qualifying the customer for a particular plan, trying to reduce repeat calls. If you give a lot of credit to customers and you really increase the default rate or you get people into trouble, these are not good for either the people you're talking to or the companies themselves. So yeah, there's work that we do on looking at sort of good agent behavior and focusing on what are quality conversations and trying to both identify those key opportunities for quality, but also sort of affect how we build our systems and how that learning is reinforced over time, to your point.
So this sort of opens up the Pandora's box of you're deploying a system of models that has to evolve and learn all of these new things relatively frequently. And, companies are releasing new products all the time or new, features. So you're having to constantly retrain and keep tabs on making sure that, okay, it's still maintaining its baseline of performance of what it was doing before. And now it's learned these new things, or we are introducing more models to this ensemble service. That really brings to mind the complexities of deployment to me. So could you talk through what sort of monitoring systems do you need in place to check all of this stuff?
Yeah, that's a great point. There's a lot of general monitoring on making sure that we're tracking to the training data set, as well as making sure we are still in domain for the types of customer questions that are coming in. One example out of domain is a couple of years ago, one of our customers, a telecommunications company, they started running a promotion for a new cell phone where they'd give you 6 months of Hulu. And so for a time window, we started getting a lot of questions about how to redeem the Hulu access, how to handle refunds, how to do all these different Hulu-related problems. And there'd never been any kind of sort of this additional add-on TV subscription or Hulu-related questions there. So we want to make sure that we can detect that customer problem fairly quickly. We can add that into our ontology, and we can start routing to the right location for the customers to get help. So we need to track basically not only are we doing well on the training set, but are we adapting to what the customer is doing in production? And I wanted to take a little bit of moment to talk about that kind of adaptation process. So at ASAPP, we think that building machine learning systems is a little bit different than building traditional software, because in a lot of traditional software regimes, once you write the code, you want the behavior of that code to be consistent. And you really want it to be consistent across basically any situation. And deviations in that are often sources of errors or bugs. In a AI-based application, once we write the code or we fix the structure of the algorithm, we want the behavior of that system to adapt and change over time. We're deploying to enterprise organizations, which are very large. And the insight there is that there's enough data in each of them that we can adapt our systems to their domain, to the specific types of problems that our customers and their customers are experiencing. If we tried to boil the ocean and build one gigantic model to cover everything, we'd have a huge long tail problem. And don't get me wrong, there are companies that have tried that. There used to be companies, chatbot companies, that would go around and saying, hey, we have 10,000 intents. We will land at your organization and we'll pick 800 out and we'll go to town. The problem with that is it doesn't really work as well as saying, we're going to do a really good job identifying this company's problems. And then we're going to design our software that over time, as we see more data, we can learn more about the types of customers' problems there are and the language they use to communicate that, and adapt our systems to actually do that. So that means thinking about building an AI system in different ways. And so we have these levels of AI systems. Level 0, which is traditional software. Level 1, where you have some training data and you annotate that training data and you build a model and deploy it. And then level 2, 3, and 4 are different sort of breakpoints about how you can adapt your ML systems in response to the data the application itself is collecting.
Fascinating. So I imagine level 4 is something that is sort of like reinforcement learning or adaptive learning, where it's like, hey, this model or this algorithm and this, not the structure, but the actual weights of a deep learning model is changing in near real time. And that's it's interesting you bring up the point about traditional software. And it's something we've talked about on the show before in previous episodes about this big schism that exists with ML engineering and ML ops software development versus traditional software and like data engineering and even traditional data science work. It's this new thing where people have to think about how to, when you deploy something, unit tests don't cut it anymore.
Right.
It's not like, hey, does it make a prediction? I mean, yeah, sure, it'll make a prediction, but does it make the one that you want or one that you're expecting? And what I'm curious is when you're going down the path, maybe not that level 4, because that's a whole different level of complexity, but maybe on that level 2 or 3, do you do stuff like simulation in sort of a staging environment when you're going to retrain something before deploying it? How do you make sure that you're catching the performance behavior that you're expecting?
Yeah, so we definitely do back testing where we're looking at, once you update a model, how is it different from the model you previously had in production? And then we will do some simulations for kind of evaluations on test data or generating synthetic things to make sure it doesn't go too far off the rails. But you raise a very good point that fundamentally bounding the behavior of the system, particularly when you start getting into pure generative modeling, is very difficult to do.
Yeah, I think there was, I don't know how many years ago it was, somebody researched or did some research and they posted it for the internet to mess around with early stage chatbot. And then Twitter got a hold of it and people just did what people on the internet do and ruined it.
That was a Microsoft Research China project.
Yeah.
They deployed the chatbot in the China market and it had learned and adapted and done actually quite well. And they decided to open up in the United States. And within a few days, it was providing responses that were slightly offensive to a large number of people.
Yeah. So placing boundaries and controls on systems like that, particularly when you're, the sort of the business model that your company's in, it's your company's reputation on the line, but also your customer's company's reputation on the line. If that automated system, even if it's augmentation, if it starts creating some really crazy stuff.
Yeah. That's a really good point. So for level 2 system, for instance, the way we think about it is you want to learn off of the data that the system is generating itself. However, you can't just continually sample data from production to test upon, because as soon as you deploy that model, you've now biased the environment that you're inside of. And you could lead into the sort of self-reinforcing problem where there's some bad behavior that is very surprising to the model. And so it's a huge weight and it learns a lot. And then it can really double down on that and get into a place where we're not very happy with it.
Mm-hmm.
So you have to have some kind of static training data that you're comfortable with. So you're continuing to evaluate the performance of the system on training data that you know is good. And it's not going to then go down some very dark place. For level 3, you need to have some way of debiasing the data that you're collecting. And so in our case, when we shift a system like our auto-compose system from level 2 to level 3, it involves a lot of work on the agent behavior that was using the model and coming up with a mechanism for unbiasing that data so we could evaluate it properly.
Interesting. So the de-weighting of activities is done based on like a statistical comparison of an agent to a pool of agents? Or like, how do you determine what that weight should be?
Yeah, basically, there's a statistical process to unbias it, to try and then to bound the behavior as well. So yeah.
Interesting. And that's something that I've seen a few companies that I've worked with do things like that, where they have a strict boundary of control when it comes to, hey, we're going to be kicking off either passive retraining or just some sort of cron scheduled retraining. Like, hey, every 2 weeks we're going to retrain, we're going to do champion challenger. And similar to what you said, like back testing, saying, okay, let's compare these two for like the last 30 days. And is it better or is it worse? But a lot of companies that are very serious in the ML and AI space and have been doing it for a while, they know about these issues where like, hey, we can't have it learn something that we're not vetting. And that's easy enough to do when you have manually labeled data or your training set is maybe a couple million rows of data. But when you're talking about the volumes that you guys are dealing with and some e-commerce site, like companies that are out there, you could be talking about trillions of events of data that could be going back in for retraining and having that statistical evaluation to say, hey, we need a human to look at all the outliers that just don't fit into this.
Yeah, that's a very good point. The human annotation doesn't necessarily scale. There are ways of mitigating that to an extent, as long as you're willing to borrow a bit more bias as well. Some mechanisms, for instance, like you can do active learning, or you can do some kind of self-supervised representation learning, and then clustering, and then you can label the clusters. That's a good way of picking up outliers, as well as decomposing the structure of the data you have. All of these are good ways of handling that large data scale problem, where the problem is not so much in the number of rows, but it's really in the variety of the problems and the size of the long tail you're handling. Because if all of those are very similar rows, then you can just sample one and your data would work out really well. When you have a big long tail and your model needs to cover a very large space, and you're adding capacity to the model to do that, then you're right that it becomes really difficult for you to vet the data going into it. It becomes really difficult to vet the process. So we spend a huge amount of time on evaluation of the model system as well. And I wanted to talk a little bit about that model evaluation, because there are proxy metrics that you might care about. And those proxy metrics may be AUC or precision or recall or some other sort of offline measures of how well the model is doing on the training data, the validation data that you have. However, what you really care about is in production performance of the system. Now, in our case, we're trying to augment agents and we're trying to automate systems. So for the agent augmentation, what we're trying to do is say measure the throughput of an agent. How many issues can an agent handle in a given period of time, like an hour? Can we make it easier? Can we save time? Can we save effort? Can we make it easier to juggle multiple different conversations at the same time? Can we improve that throughput? So we do regression models, statistical regression models, usually Bayesian hierarchical regressions, to try and estimate the impact of our systems on the downstream KPIs we care about. And then we can validate those with experimentation. So we can detect the causal structure that we're trying to do, write down the DAG that we figure out in the experimentation, and then we can estimate that with observational data going forward. And so we keep a really close eye on metrics. And we've seen issues where, gosh, we've had gigantic improvements in offline AUC on classification tasks. And we go and deploy that into production. We see either a drop in usage or no change, and we see no impact on the actual measures we care about. And then sometimes we'll see like a marginal improvement in AUC, and we'll see very large gains in either adoption or throughput. And so there's this proxy problem where if you're a little bit too laser focused on the bits that's easy to see, if you're working on your machine learning model, you can lose sight of the value you're trying to contribute as part of the AI system you're building.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. You know, whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
Geez, that's like a mic drop moment for this entire podcast. Historically, it's a common theme that we talk about we've done entire episodes of just focusing on stop paying attention exclusively to your validation metrics. Cross-validation is great, but if that's the end of the story for you, once you ship that to production, if you're just saying, hey, the accuracy was 89%, we're good to go, and you don't monitor it, 3 months later, some executive is going to come down and say, hey, by the way, that thing that we spent 10 months building and it's costing us $5,000 a day to run this thing, how much money is it making us? And if you're like,
sure,
I don't know, it's really accurate though. But it seems like that's such a critical component. And obviously your company has this figured out, because you wouldn't be a company without those systems in place. But to all the listeners out there, even if you're developing something just for your company for an internal use case, you really should be thinking about it from exactly as Michael just said, about why are we building this thing? How do we measure if the effort and time and money that we put into this was worthwhile? And how do we make sure it continues to improve over time?
Yeah. And Ben, that's a really great summary. And I wanted to pull in a thread there of how do you ensure it continues to improve over time? One of the really fun things about machine learning systems, and particularly with the easy availability of, say, pre-trained language models or image models or other pre-trained models around, is you can get a prototype up and running like astonishingly quickly in a matter of days. And you can have really good accuracy on that system itself. And if you do your cross validation and you mark it down and you say, hey, the system's amazing, it's great, let's just rush it to production. Then you might be surprised 3, 6, 9, 12 months later when you've started to see the sort of drift in model performance, that you have sort of domain drift or data drift or just general distribution shift, covariate shift, whatever you want to call it. The data you train on is a sample from a certain time slice in production. And if you're not aware of how the distribution of your data changes over time, you can run into some really awkward, embarrassing issues very quickly. Your model can degrade surprisingly quickly. And so you want to build some mechanism for improving that system over time, which is what, the sort of jump from level 1 to level 2 is in the framework. It's how can you incorporate the data from production into your system so you can place guarantees on the level of degradation or non-negative degradation once the system is deployed.
Yeah, that really brings to mind another topic that we've discussed in the past. I'd really like to hear your opinion on it, on deployment strategies in a situation that all your chips are on the table when you're an ML AI company that offers a service like what you do to other companies. Because they're not going to be able to build this themselves. And they shouldn't. A phone company shouldn't be hiring a team of 50 AI PhD researchers and 50 software developers to build an internal system just for this. So when we're talking about making sure that we're responding to drift over time, sort of the deployment strategy of that, we kick off retraining, we do that validation, we do the back testing on historical data. Do you typically do a champion challenger, or do you do for sort of a traditional A/B test on something, or do you have to stay in shadow mode for something like that?
Yeah. So for our case, it's going to vary a little bit on the specific model. Some models we can kind of evaluate the performance statically, and other models are dynamic. So take our autocompose system. Autocompose, among other things, provides a suggestion to the agent of the next thing to say. That's not something we can reliably run in shadow mode, because when we present that to the agent is providing the sort of soft biased annotation of the result. And that also, customizes the next, we adapt it to the agent behavior over time. So we'll run like a canary test to make sure that everything looks the same. And then we can run full blown experimentation as well to make sure that nothing looks wrong and all the metrics are comparable. And then we can do a full deploy. So yeah, we have a very, very robust A/B testing system where we can deploy these systems at some percentage of traffic. One of the things we ran into actually that was not immediately obvious before we started was because we're focused on augmenting agents. There's a lot fewer agents than there are, say, turns in a conversation or customers or something else like that. So if you have even a few hundred or a few thousand agents, there's significant cluster data problem where individual agents have quite varying behavior. And so if you just do like a standard t-test or you do some sort of basic statistical evaluation, then you're gonna see quite different results depending on what agents have actually handled the conversations. So you need to step a little bit into like hierarchical Bayesian or random effects type world where you're doing more sophisticated statistical modeling to estimate the impact of these systems. To make sure that they actually are the same or different.
Yeah, I've seen that same exact behavior with stuff in previous industries I've worked in, like in e-commerce years and years ago. We saw the same sort of biased behavior based on the solutions that we were presenting to customers. And people don't think about that. They think, I ran my A/B test. Here's this group of 1.8 million people that are going to be in control, and then we're going to do a test of 3.8 million people in test.
Right.
And they run the numbers with a studentized t-test, or even worse, like a z-score test. Yeah. And they're like, look at this lift. I'm like, that's not real. Like, not even close. And they're like, well, what do you mean? Like, well, there's latent variables in people's behavior. And look at the types of activities that these people do. There's so many latent factors in this very limited time window that we're looking at, because in your test group, you have 80% of the people that do massive purchases one time a year are in there. And then the 20% of people that do massive one-time purchases every year are in control. So you're lumping all of those together. It's going to look way better than it actually is. So we need to identify cohorts, and we need to actually run like 200 separate statistical tests on these groups. And then we can see that stratification, and that'll tell us what the lift is per group. And
yeah, absolutely.
Yeah, I imagine with the agent issue, I mean, there's almost an infinite number of latent variables that go into that. And by disambiguating that, by saying, we're going to put this, as you said, that random effects model and saying, we don't know what's different, but we're going to tell this algorithm that there is a difference here that is unexplained. Now analyze it. That's a very smart way of doing it. And kudos to all of you for figuring that stuff out.
It did take us a little while. I'm not going to lie about that to land on something that had the correct properties in terms of reliability and error rate and things like that. I'm sure I don't need to tell you that small variations in your model formulation can have quite large implications on the effects you measure. But yeah, that's exactly the same type of thing. When you have bias, doing the sort of, what you might think of as a rigorous thing, which is a statistical test, is not always great. And even worse, if you're say have 200 KPIs you care about, and then you happen to pick the ones that have a positive t-test result on, and therefore justify the success of your system, which is also something that people do. So pre-registration of what you care about is important, as well as appropriate estimation of the KPIs, and trying to be really diligent about saying, hey, we want to drive real change here. We're less interested in justifying the system than we are in using it for our R&D process over time, because we're not, as a software company, and particularly as a software as a service software company, we're not trying to win this one study. We're trying to build a system that continues to improve over time. And we need to be really rigorous about what we tell ourselves so that we know what the true effect is.
I don't think anybody could have said that better. That is the goal of a SaaS company, and particularly when you're dealing with ML deployments. And taking that back to what you said at the beginning of the call about measuring the sort of KPI metrics as the general, quality metric for the entire service that's been deployed. I think we as humans, particularly if it's something that we create or our team creates or our company creates, we're inherently biased to want to just naturally pay attention to the positive results. Like, hey, we got this massive win. Look at the performance lift in this. Like, hey, this call center is now churning through calls at a 200% faster rate than it was before once we deployed this new version of the model. If we're not skeptical as like ML people that are handling production systems and saying, is that too good to be true? Let's actually dig in and see what happened here and not believe those massive positive gains, but also not ignore the negative signals as well. That sort of forces that agile process of saying, we need to improve this. We need to add, additional controls and features and make sure that we're not beholden to our inner human desires of wanting positive change in something that they're working on.
And Ben, you raise a really good point about that, because even if everybody is super diligent and everybody cares deeply about the truth, positive news is going to travel faster and further than negative news in an organization. So you need to be careful about how you communicate results. And at least what we found is that looking over time really helps. Because if all people have in their head are the last 5 success stories, and they never heard about the 12 failures, then they might have a different conception of how things are looking. But if you can show the relative effects and the change in the system over time, you can help calibrate people as to, this is what's actually happening, this is where we're going, and this is sort of a more realistic picture of the system as it's been developing.
And also that time horizon, speaking from personal experience, is important to tell that story to everybody who's involved in it. I've seen people do it before, and I was guilty of it at one time, saying, I am just going to report the last 2 quarters of results on retraining, and what that ends up doing is biasing executives' minds when they see that chart.
Exactly.
They're like, hey, what's with that massive dip this last time? We can't release that, and we can't do, we need to shut this off. And they're like, hold on a second, let me just move that x-axis over back to 6 quarters ago. And they're like, oh, okay, 80% improvement, got it. And it's
exactly.
we didn't know what we were doing when we first started doing this, just like everybody else. We're just making it better over time. But yeah, I think that's important for level setting, and also not to hide failures.
For sure. The hiding failures is, we don't want to publicize those. And we're interested in being as scientific as possible about the research work we're doing and the engineering work we're doing. because that's how we build trust in ourselves and we can deliver more consistently over time. I wanted to talk a little bit about the whole we don't know what we're doing when we get started, because I think that's kind of important. One of the really nice things about a lot of the pre-trained systems out there and the really high performance of all the deep learning models out there is you can do prototyping really quickly. And I kind of glossed over that earlier and said that, well, you run into production problems, and that's true. But very often what we've seen is that what takes a lot of time is formulating the problem in the right way. So when we started off with our auto-compose system, for instance, like 6-7 years ago, we had a formulation on training data where we had some data, we annotated it, and we trained it, and then we upped the model complexity a few times, shifted from like a very basic register regression to a deep learning system, and then to recurrent deep learning system, and a bunch of bells and whistles. And all these were great, but we only really started having it take off where we shifted the problem formulation from trying to do this training data to production split to where we're actually learning off of the production data itself. And so as you're iterating on the problem definition, and as you're iterating on how you understand the impact of the system, it can be really helpful to live in this kind of prototyping land where you're moving really, really quickly. And then once you've nailed the problem formulation, it can be really helpful to start thinking about how you're going to scale that up and scale that out and build an AI system that is going to change and develop over time.
What you just explained with your progression on that solution from 7 years ago, we did a 2-part talk on this many, many months ago about starting relatively simple, and then you bolt on complexity as you need it, but you only know if you need it or not by collecting data and saying, is this solving the problem that we want to solve? Can we do better? But at least you have that baseline to move fast and iterate, and then you learn as you go. I think that's why we're talking today, because you guys have this figured out and are continuing to figure new things out. So if I could ask you one thing about what this process is like, and what do you think the future holds for the company that you work for, and how are you going to grow, or what are you going to get into next?
That's a very, very complicated question. I think that where, what we're doing now is we're trying to build the best AI systems and services that we can. And we spent a lot of time recently building what we think is the best ASR system in the world for contact centers. And, I'm very impressed that the team has managed to drop, say, median latency by like 10x from like 2 seconds to 200 milliseconds in the past couple of years, while significantly improving the performance itself. And a lot of these are enabling technologies that we're building and deploying. So how do you enable organizations to consume ASR? How do you convert phone calls and contact centers to a useful real-time data feed that you can then put other things on top of? And then how do you take some of our systems, like whether it's knowledge-based recommendation or workflow recommendation or what to say next or evaluation of sort of customer happiness and satisfaction, and how do you start stitching those together into a system? We do this in our full platform, and we're trying to expose some of the individual enabling technologies to people to really be able to plug them into their systems and start to say, what can we do now? What can we do next? Where we're really starting to think about what these things open up and enable. And we have a lot of ideas, and we're very excited to see what kind of ideas our customers have about how we can really, what we can do once we have the baseline enabling ML technologies in place.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
So instead of one of those things that you mentioned, instead of operating as a sort of a traditional SaaS company of somebody has to create some sort of front end for the customer service rep to have open that is basically calling REST APIs to your service saying, like, here's the text that's going on. What should I respond? You're talking about taking your application and allowing a customer to embed that in their internal systems.
Well, taking a step back, this is more business and deployment concerns. So we have a full application suite where we can land that at a customer and sort of do everything, both for voice and for digital messaging. And then we also have APIs that people can consume if they just want an individual component there. One of the things that we're aware of is that a lot of the technologies we're dealing with are enabling technologies where we're doing some things for the agent And there's a space of things we can build on top of that. So we have sort of systems building on top of systems, and we don't want to be too circumscribed about what that is. But we're definitely focused on the ASR. We're focusing on the agent augmentation. We're focusing on sort of real-time coaching and how we can help evaluate the systems over time, what we can do automatically for customers as well. So there's sort of areas that we're interested in and we're working on, but I don't know if I can reliably say we're definitely going to do X in 3 months.
The interesting thing to me about what you said about what the future is that my take on it is you've already done all of the incredibly challenging work that is basically process related, of saying, regardless of what project we're going to work on, we know that we're going to measure it this way. We're going to think through the problem, through this lens. We're going to use the appropriate technology to iterate quickly. And every large company that I've worked with that is super successful with whatever they're doing in this field, they all have that same mindset of taking this scientific rigor and the skepticism, but also a strong but flexible process around how do we deliver value with AI and ML. And my response, or my argumentative response to you, is I don't think there's anything that you guys wouldn't be able to do in whatever venture you're doing, because you're on the golden path of how to build systems that will work. It's exciting.
It is very exciting, and we do focus a lot on the R&D process and how we build systems. And then what comes out of that is, we have a lot of really interesting focus areas on task-oriented dialogue or better speech or other projects we have. But what comes out of that is really a function of the process itself.
Couldn't have said it better. All right. So this was a far more interesting talk than I think I was prepared that it was going to be. And I was already prepared that this was going to be interesting after checking out your website and seeing some of the blogs that everybody's written on your research teams. Yeah, just thanks again for coming and chatting about all of this stuff, about real world, like how to actually get things into production, keep them there, make them better, and solve real problems that really need to be solved. So in closing, is there anything that you'd like to mention about the company, about research that you guys are doing, how people can get in contact with you?
Yeah, absolutely. We're always hiring, particularly for ML engineers and research scientists. So please, if you're interested in anything discussed here, then reach out to me or generally to ASAPP Careers. And we're focused on a lot of really interesting things, I think. So there's a lot of the ASR stuff we're doing, and a lot of the task-oriented dialogue stuff we're doing, a lot of generative modeling applications that are super interesting as well. So there's a lot of things we're covering in the contact center space, and trying to really think about how we go from, what is the problem to what is a sort of AI first or AI native solution to that problem, and how do we build and deploy and scale that so they can benefit our customers and improve over time.
Yeah. One thing I'd like to add to that is definitely check out the blog that they have on their site that a lot of their engineers and researchers contribute to. It's always awesome to see a SaaS company that encourages its native geniuses to contribute knowledge to the world like that. It's really great content, and I got a real kick out of reading through a lot of it.
Happy to hear that, Ben. Thanks for having me on the show.
All right. So until next time, I've been your host, Ben Wilson. Thanks for tuning in, and we'll catch you next time.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.